Hello, this is Manisabhadra from NIT Raurkela. I am going to explain about Maxwell bridge. Maxwell bridge having two sub experiment: Maxwell inductance bridge and Maxwell inductance capacitance bridge. So we required Maxwell bridge trainer, digital multimeter and 10 patch cuts. Okay, now we are doing the experiment. So first Maxwell inductance bridge. First we have to connect patch cord from terminal 1 to 2 and take another patch cord and connect from 8 to 11 terminal, and next connect to null detector by using the terminals 15 and 17, and next take another patch cord, connect in 16 and 18 terminals. Next you have to connect sine wave generator with the Maxwell inductance bridge. So sine wave generator 29 to 30. After connection, let us start the power button on and trainer power button on and null detector power on, and this amplitude control always in maximum position. Maximum means 1 kHz, and this potentiometer in minimum position. So first we have to switch off and reset it in fully anti-clockwise direction, and then switch down the null detector and vary the potentiometer when the noise is minimum. Vary the potentiometer very precisely. Here the sound is minimum. Then switch off the null detector, switch off the power button and disconnect the wires, connecting wires. And take the reading. Take the value of R2 using multimeter. It is set in 2000 ohm or 2K. Next we have to take the reading by using multimeter. What is the value of R2? Here I will check the value of R2 is 106. So now here R2 is 106, R4 is given 100 ohm and R3 is 470 ohm, L1 is 12 microhenry. So we have to find the Lx. So Lx equal to L1 into R2 by R4. So L1 equal to 12 microhenry, 12 into 10 to the power minus 6 into R2 equal to 106, and R4 is 100 ohm. So 100 ohm. Then by using calculator, 12 into 10 to the power minus 6 into 12 into 10 to the power minus 6 into 106 divided 100 equals to 1.272 into 10 to the power minus 5. 1.27 into 10 to the power minus 5. So 12.7 into 10 to the power minus 6. 12.7 microhenry. This is the result of Lx. So here 12.7 microhenry. Then let us find what is the value of Rx. So Rx is R2 R3 divided by R4. So R2 is 106, R3 is 470, R3 is 470. This one fixed. R31, R32, R33 divided by R4 100. So we have to calculate 106 into 470 divided 100 equals to this one 498.2 ohm. So this is the calculation part. Okay, you write here 2 ohm. Then do for next. So let us start for calculating Lx2. So connect as per circuit diagram. Take one patch cord, connect from 1 to 3 and connect from 8 to 10. Connect from 15 to 17 terminal. Next 16 to 18 terminal, and connection between 13 to 29, and this one 30 to 40. The connection for calculation Lx2 is over. Rotate the potentiometer very preciously where the noise is minimum. Let me check. Here the noise is minimum. Then switch off the null detector, switch off the power supply, switch off the main power supply, disconnect the patch cords properly, and take the value of R2. Here you have to write the value is 37. Here 100, R3 4 1000 ohm and L1 12 microhenry. Then you have to calculate using this formula, calculate this value, and using this formula or this formula you have to calculate the value of Rx3, and then you calculate the average value of Rx here. Okay. Now Maxwell inductance bridge is finished. Maxwell inductance capacitance bridge. This bridge is used for calculate the Q factor. So first switch on the supply, main supply, then connect the patch cords 21 to 22. Connect the null detector. 19, 17. Connect the null detector. 18, 20. Connect the sine wave generator. 26 and 29. And another patch cut 30 and 27. Connection for Maxwell inductance bridge is over. Let us start the experiment for calculating the value of Lx for Rx1. The connection for this is over. So first switch on the 10 power supply, switch on null detector power supply, and this potentiometer R7 must be in fully anti-clockwise direction, and this amplitude control in maximum position means 1 kilohertz. So now we have to rotate this potentiometer very precisely. So you have to rotate this potentiometer R7 very precisely, slowly, and check where the noise is minimum. Here the value is here R7 is 137 ohm and R5 is 221. It is written. R6 is 1.122 kilo ohm. C1 is 330 nanofarad. So find out Lx. So Lx equal to R5 into R7 into C1. So R5 is 221. Into 137 into 330 into 10 to the minus 6 equals to. So here 9.99 into millihenry. Okay. So here 9.99 millihenry. So next find Rx. Rx equal to R5 into R7 divided by R6. So R5 is 221. R7 is 137. And R6 is 1.122 kilo ohm means 10 to the power 3. So we have to calculate 221 into 137 divided 1.122 divided 1000 equals to 26.98 ohm. So here 26.98 ohm. So find out Q. So Q equal to omega Lx by Rx or omega C1 R6. So what is omega? Omega is 2 pi f Lx by Rx. So 2 into pi value 3.14 into f. F is 1 kilohertz. You know, amplitude control must be set in maximum position 1 kilohertz. 1 kilo is 1 into 10 to the power 3. into Lx. Lx value is 9.99 millihenry, millimils 10 to the power minus 3, divided by Rx. Rx is 26.98. So you have to calculate 2 into go for the next reading, Lx5 and Rx2. Connect the patch cord between 21 and 23. Connect the null detector to 17 and 19 and another 18 to 20, and connect the sine wave generator from 26 to 29 and this one 27 to 30. Now the connection is over. Let me check the amplitude control in maximum position and the potentiometer in minimum position. So let us start. Switch on the power supply, switch on the null detector and vary the potentiometer very precisely where the noise is minimum. That was the balance condition of this bridge. So rotate the potentiometer very precisely. Here sound minimum, disconnect the wires and take the value of R7 using multimeter. Here 437. So next you have to calculate the value of Lx by using the formula R5 R7 into C1 and calculate the value of Rx by using this formula R5 into R7 by R6, and then you calculate the Q factor of Maxwell inductance and capacitance bridge method. So this is over. They connect the circuit diagram for calculating Lx6, Rx3. So 21, 24, next 17 to 19, 18 to 20, and the same sine wave generator connect to 26, 29, and this one 27 to 30, and next this potentiometer must be in minimum position, amplitude control in maximum position, then switch on the power supply and switch on the null detector and rotate the potentiometer very precisely where the noise is minimum. That was the balance condition of this bridge. So sound is minimum. So switch up the null detector, switch up the power supply, and disconnect the wires and take the reading of R7. R7 is Then go for the calculation. So here 427 and calculate the value by using same Rx equal to R5 R7 C1 and Rx R5 into R7 by R6 and calculate the value of Q. Thank you.